asks us to write the equation of the nth term of the following geometric sequence. Okay, because it's geometric, that should tell us that r is going to be multiplied by something. So this right here means what is it multiplying by every time. Now it could be a whole number, it could be a fraction. A sub 1 means your first term, and then this is basically saying like y equals. So here y equals our first term. Well, our first term is 2 times, well, what's happening to each one of these? Well, if I multiply by 5, I get 10. If I multiply by 5 again, I get 50. If I keep going, that's where I'm going with that. So our r is 5, and then n minus 1. So since all it's asking for is for you to write the equation for the nth term, well, there's n. There's your answer. Now you could have written a sub n, but it's the same thing as y equals. Alright, now this time it's telling us to find the 25th term when our first term is 3 and our common ratio is 2. That should say ratio. So our first term is 3, so that would go here. Remember, a sub n is just the same thing as y equals. So 3 times our common ratio, which is 2, and then n minus 1. So what we're going to do is we're going to go to y equals, and we're going to plug that in. So I'm going to go to y equals, and I'm going to type in 3 times 2 raised to x minus 1. And now I'm going to go to second graph, and I want to go to the 25th term. So the 25th term, if you look at it like this, it looks like a weird number. It has e to the 7th power. Well, if you scroll over, it gives you the exact number right here. So our number is 5,033, 648. So that is our 25th term, and if you want to get technical, you could write it like that. So this is saying that the 25th term is 5,033,648. Okay, on number 9 there was an error. I need you to go ahead and scratch out that second one and write this as your second one. So on this one, it's asking us to identify the sequence as geometric, arithmetic, or quadratic. Well, I just talked about geometric. If it's geometric, you're basically multiplying by the same number on all of these. So here, I'm technically multiplying by 1/2. And it gets us the next new term. So this is actually geometric. Now this next one's a little bit different because I don't think we've talked about it in this scenario. So here it increases by 3, by 5, by 7. And there go my dogs barking. Alright, and now from here to here, it's changing by 2. So this is arithmetic. I'm sorry, not arithmetic. Quadratic. And the reason I know that is because the second change is the same. Now on this last one, this is arithmetic because it's increasing by 1 every time. So if the change is the same, then you need to know that it's arithmetic. Okay. Number 10. y'all should know we talked about these kinds of questions. It's a stat question. We have a table. It's asking for an equation. So if you look here, it's telling us specifically quadratic. So when you go to stat, you should know that you're pressing 5. And the reason why we're pressing 5 is because it says quadratic. If it would have said exponential, we would have pressed 0. If it would have said linear, we would have pressed 4. Okay, let me turn this float off because it's going to throw some of y'all off. Okay, so stat enter. So I've already typed this in. So L1 are your X's, L2 are your Y's. So now I'm going to go stat. We want to go to calc. Again, we want a quadratic regression. So we're going to go to 5. And then we're going to press enter until we find the equation. Now, if you look, I already have it in that standard form. Now I'm just going to use the calculator, and it tells us specifically to round to 3 decimal places. So if you look here, is that 9 going to round up, or is it going to stay the same? Well, that 2 means we're going to stay the same. So we have y equals 1.209x squared. That 8 will round up because of the 5. So this is plus 12.999. Again, there goes my dogs. And then the last one would be C, which is going to stay 7 because the 1 does not make it round up. So I have 504.257. And that's your equation. I apologize for my dogs, guys. Alright, so now this last one, using the quadratic model from the problem number 12, what will the estimated population in 2030 be? Actually, it says what will be the estimated population in 2030. Okay, so here's basically the table that we were looking at just a minute ago. Now, the reason why I did this is because sometimes I see kids coming down and they're trying to go to 2030 to see what that number is. You got to keep in mind that that 0, that year 0, is 2070. So when it says year 10 isn't 10, it's actually 1980. Then it would be 1990. Then 2000, 2010, 2020, 2030. So what year is that since? It's since year 60. Okay, so now I'm going to go to y equals. I'm going to put this equation in y equals. Yes, it's going to look really weird because of the way, because of the decimals that we have to put in there, but it's okay. We will survive, just like my dogs that are barking. A second graph. I want to go to 60. So if you look here, 60 is roughly 5,637. And that's our answer. Again, I apologize for my dogs. Y'all have a good day.